Hello students, welcome to video lecture. From today onwards we are going to start unit 5. The first topic of unit 5 is introduction to R programming, and this video we are going to cover first part of R programming. So let's start with the introduction. Basically, R programming language or software environment is used for the statistical analysis, graphics representations, and reporting purpose. R was created by the Ross Ilhaka and Robert Gentleman. So both the creators were initially start their name with the R. That's why this programming language is known as R language. This is created at the University of Auckland, New Zealand, and later on it is developed by the R Development Core team. R is freely available under the general public license, and pre-compiled binary versions are provided for the various operating systems like uh, Linux, Windows, Mac, Macintosh, etc. The core of R is an interpreted computer language which allows branching and looping as well as modular programming functions also. R also capable to integrate with the procedure written programmings like C, C++, .NET, Python or Fortran languages for much more efficiency. As far as features of R is concerned, R is well equipped, well developed, simple and effective programming language which includes conditionals, loops, user defined recursive functions, inputs and output facilities, all the basic necessary things that are required. It also have a effective data handling and storage facilities. It provides a suite of operators for the calculations on array, list, vectors, matrices, and many more. R is capable to provide large, coherent, and integrated collections of tools that are widely used in the data analysis field. Are also capable to provide graphical facilities for data analysis and display either directly to the computer or printing at the some papers. So let's start with the basic program syntax. In this program syntax, I have written a very small program with two variables and displaying their values. So the very first line is start with the hash. Hash is here comment. Commenting is very much important in programming. Basically, comments are like helping text to understand the purpose of coding. It is neither executed nor compiled. But remember one thing, as far as our programming is concerned, theoretically there is no multi-line commenting in programming R. Although tricky basis we can use it by using writing a text on double quotes. So it's a simple instructions to the R interpreter that if it is written as double quote without any command, then it can be ignored by the compiler. So in that case we can use this shortcut. Here we use two variables, myStrings and num1. But you remember that we don't mention any type of return type of your variable, means no return variable here. Similar to Python, it also identify by its value. So in my string I have stored hello world, that is string. It's automatically identified that my string is a string type of variable. In second variable I use a number 10. It means it can easily identify that this variable contains a numeric value. Simple, I can print both the values, my string and num1, and here you can see the output. Whatever I written in my string printed as it is, and whatever I store in num1 it also printed as it is. Next we discuss about the R data types. So these are the few basic inbuilt data types used in R. Although we are also going to explain specific data types that are powerful in R. So first one is logical. Like the other programming languages, we also use true and false capabilities in R. Numeric for the numeric facilities, integer, complex, characters and raw. These are the basic 6 types of data types. I also quoted in this slide about their code of use to print their class, which class do they belongs. So if a variable holds a value true and I want to know what is the data type of this V, then I can write this as print class V, means what is the class of V variable. So in output you can see it is a logical. So which type of data types you are using, you can identify with this code. Now let's talk about the specific data types. So in our objects we can use common data types. Here data types can be treated as R objects. So we have vectors, list, matrices, array, factors and data frame. These are the frequently used data types in R language. Let's discuss with vectors. When we want to create a vector with more than one element, we should use a C function. This provide a basic functioning to add, and we will see this function in many other data types also. So basically vector elements can be combined by these functions. As an example, I have created a variable apple and using the C function I initialize it with red, green, yellow. I use 3 colors. Then I print apple and I also check which type of data type is gained by this apple variable. So I print class and apple. As far as result is concerned, this code will result as red, green, yellow, and the type of apple is character because it stores the value of colors, that is string values. To next data type, that is list. List is an R object which can contains many different types of elements inside. It's like a vector functions. So for this demonstration, I have created a variable list1 with the function of list and vector function that stores 3 type of different values. I have stored here numeric value, then I have another numeric value and a functional value. And then I print the value of list. So variable of list1 is list1 and that is to be passed with the print function. The expected executed code result is shown here. In first, we have stored in vector 253. It is displayed as a first row. Then I have passed to 21.3 as a second value. And lastly, I pass a sign value, but that is required a function x primitive sign, so it displays that you have passed on a sign primitive. So this way we can use the list. Next is matrices. So matrices is basically nothing but two-dimensional rectangular data set that can be created using a vector input to the matrix functions. To create a matrix, we must use a matrix function along with the vector functions. Here we created a variable m and pass on the value a b c b a, and in this we have to define number of rows, number of columns and y row value true or false. Let's take a boolean. If I want to print this matrix, I pass on m into a print function, and as I mentioned the 2 row and 3 column, so this code will be displayed as 3 column and 2 row. and if you see the value, it is sequentially assigned according to input that I enter A, B, C, B, B. So this 3 is represented in one row and rest of the 3 is represented as another row. Next is array. As we know that array is a continuous memory location, but here array in programming R can be of n dimensional array, while matrix we have already discussed before that is two dimensional. Array can be any number of dimensions. The array functions take a dimensional attribute which creates the required number of dimensions. For the showing example, we are using a 3 cross 3 matrices to display the example. Here we created a variable named a with the help of array and vector function. Here we store green and yellow two string values, and we define the dimensions of C, that is 3 rows, 3 columns, and 2 times this one is repeatedly. Now we have to print this value, print A. Now see the output. In this, we define 3 columns. Here is, we define 3 rows, and we further define 2 times repetition of this code. So this is one iteration and this one is a second iteration. So totally we have a 2 iterations with 3 row, 3 columns. If we talk about 3 cross 3 cross 2, so I have total 18 values, and see 9 plus 9 is 18 values. Now what happened with the data representations? We have to display 18 times a value, but I have stored only 2 value. So the repeated value will start green, yellow, then green, then yellow, then green, then yellow, and so on, continuously represented. So we can define n dimensional data using the array here. Next one is factors. Factors are also the R objects that are used to create using vectors. Basically, it stores the vector along with distinct value of the elements as a labels. For example, somewhere we have to use many values, means categories. To use that category, factors are used. We'll see this in an example. Labels are always character irrespective of whether it's numeric or character or boolean. Factors are created using the factor function, and it also has an n label functions to identify number of labels or count of labels. Let's see an example. I have created a vector name as apple color, and I store the value green, yellow, red, green. These are the possible values that apple can hold by its color. Now I create a factor object, factor apple by function using factor, and I pass the apple colors. Now I am going to print factor apples, mean the existing values, and then I want to print n labels of factor apple. I pass the function n label with print, and then it pass argument as a factor apple, this one. So according to the executions results, first function, that is print factor apple, will print the values, this one that I stored, and the factor apple labels is represented as green, red, and yellow. Here this function is identify the number of unique categories. We have only 3 categories to display this, so such type of the functions required factors. Next is data frames. Data frames are tabular data objects. Unlike a matrix and data frames, each column can contains different modes of data. The first column can be numeric, while the second column may be a character or something else, or third one is different. So it is basically a list of vectors of equal length. To create data frames, the data.frame function is required. Let's see by example. So I create a data frame, frame.bmi. In this, I define a data frame, that is gender must be a male, male, female, height is respectively 152, 171, so on. Similarly, I add bits of each and age. Now, when I print BMI, it displays me like this: gender, height, weight and age, and it display all the relevant values. For value 1, it's a male as a gender, height is 152, weight is 81 and age is 82. So this data frame is much useful in statistical analysis. In this video we are including these basics. We'll continue with next video, that is basics of R programming part 2. Thank you for the watching.